We're going to Mars, not just to visit, but to bring a piece of it back home. Sounds simple, right? Grab some rocks, put them in a box, slap on a return address label. Well, not quite. Getting to Mars is hard, landing on Mars is harder, and getting stuff Mars to bring back, that's a whole other level of hard. NASA has been chipping away at a plan for years. It's a multi-billion-dollar, multi-stage affair with more moving parts than a Swiss watch. But recently, a small but ambitious company, Rocket Lab, threw their hat in the ring with a proposal of their own. Their pitch? Faster, cheaper, and using tech they say is ready to go. It's a bold claim, and it has the space community buzzing. Can Rocket Lab really pull this off, or is this a case of biting off more than they can chew? To understand, we have to look at both plans, the technologies involved, and the potential consequences of success or failure. Because this isn't just about bringing back souvenirs, it's about the future of Mars exploration, and who gets to write the next chapter. NASA's current Mars Sample Return (MSR) program is a behemoth, a complex ballet of spacecraft and rovers designed to work in perfect harmony. It starts with Perseverance, the plucky rover already trundling around the red planet, diligently collecting rock and soil samples. Perseverance is just the opening act. The next stage gets complicated. NASA is considering two different architectures, both involving multiple launches and intricate maneuvers. One option uses a European Space Agency (ESA) fetch rover to collect Perseverance's samples and launch them into Mars orbit. The other relies on Perseverance to meet a lander with a mini-rocket, the Mars Ascent Vehicle, that will blast the samples into space. Once in orbit, the samples rendezvous with an ESA spacecraft, the Earth Return Orbiter. This spacecraft then carries the precious Martian cargo back to Earth, where it will land in the Utah desert. The current estimated cost for this intricate dance, a cool $10 billion, and the timeline, if all goes according to plan, and in space exploration it rarely does, expect the samples back on Earth sometime in the 2030s. Rocket Lab, known for its smaller, more affordable Electron rocket, proposes a radical departure from NASA's complex and costly approach. Their plan hinges on existing technologies and streamlined operations. They aim to achieve what NASA wants, but faster and for a fraction of the cost. Their secret weapon? Photon, their versatile spacecraft platform. Rocket Lab plans to utilize two Photons, one acting as a lander and the other as a carrier. The lander, equipped with a robotic arm, will retrieve the samples cached by Perseverance. Then, using a heat shield and parachute system, the lander will send the samples back into Mars orbit, where the carrier Photon awaits to ferry them back to Earth. Rocket Lab estimates their mission could be accomplished for a mere $1 billion, a tenth of NASA's budget. And the timeline? They believe they can have Martian samples back on Earth by the mid-2020s, shaving a decade off NASA's projections. It's an audacious plan relying heavily on proven technology and rapid development cycles. Section 4. A difference in philosophy, speed versus security. Rocket Lab isn't shy about criticizing NASA's approach. Peter Beck, Rocket Lab's CEO, has publicly voiced concerns about the agency's slow-moving bureaucracy and ballooning budgets. He argues that their reliance on traditional large-scale missions stifles innovation and delays crucial scientific discoveries. "We can't afford to wait decades," Beck once stated. "The time for action is now." His words reflect a growing sentiment in the space community. Organizations like the Planetary Society have also expressed concerns about delays in NASA's Mars Sample Return program. They argue that each year of delay increases the risk of losing the cached samples altogether, jeopardizing a once-in-a-generation scientific opportunity. NASA, however, maintains that their cautious approach is necessary for a mission of this complexity. They point to their long history of successful missions, emphasizing their commitment to safety and scientific rigor. The agency argues that the sheer scientific value of the samples warrants a meticulous, deliberate approach, even if it takes longer and costs more. Section 5. The Stakes, a Future on Mars. The debate over the Mars Sample Return mission extends far beyond budgets and timelines. It represents a larger philosophical question about the future of space exploration. Should we prioritize speed and affordability, potentially at the expense of risk, or should we stick with the tried and true, even if it means slower progress? The implications of this decision are significant. The success of a privately led mission like Rocket Lab's could usher in a new era of commercial space exploration, driving down costs and accelerating the pace of discovery. It could also lead to more innovative, risk-taking ventures, pushing the boundaries of what's possible beyond the scope of government agencies. However, failure could have the opposite effect. A high-profile setback for a private company could erode public trust in commercial space endeavors, leading to increased regulation and potentially hindering future partnerships. It could also bolster the argument for a slower, more measured approach, reinforcing the idea that deep space exploration remains the exclusive domain of government agencies. Section 6. Can Rocket Lab deliver? A question of capability. While Rocket Lab's proposal is undeniably ambitious, questions remain about their ability to deliver. Can a company primarily known for launching small satellites into Earth orbit truly handle the complexities of an interplanetary mission? Rocket Lab argues that their experience with the Electron rocket and the Photon platform, combined with their nimble and adaptable approach, makes them uniquely suited for the challenge. They point to their successful missions, including lunar missions and interplanetary missions, as proof of their capabilities. However, skeptics remain. They point out that a Mars sample return mission presents a significant leap in complexity and risk compared to anything Rocket Lab has attempted before. The Martian environment, with its thin atmosphere and unpredictable dust storms, poses significant challenges for landings and launches. Additionally, the sample retrieval and return process requires a level of precision and coordination that Rocket Lab has yet to demonstrate on this scale. Section 7 Conclusion: The Next Giant Leap. The debate over the Mars sample return mission highlights the evolving landscape of space exploration. With private companies like Rocket Lab entering the fray, the traditional model of government-led missions is being challenged. This competition, while potentially disruptive, has the potential to accelerate progress and drive innovation. Whether NASA chooses to stick with their own plan or partner with Rocket Lab, the success or failure of the Mars sample return mission will have far-reaching implications. It will not only determine the future of Mars exploration, but also shape the role of commercial space companies in humanity's quest to explore the cosmos. One thing is certain: the journey to Mars is fraught with challenges. But as John F. Kennedy once said, we choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. The same can be said for Mars. And whether it's NASA, Rocket Lab, or a collaboration between the two, the quest to unravel the mysteries of the Red Planet will undoubtedly inspire generations to come.